Hello, everyone. Thank you for being with me today. So today I'm gonna present a topic that is not that recent. It's something we've been talking about for a while now. We call it often DeFi pooling, and what it is in a nutshell is a way for you to build applications that live on L2, that give your users L2 experience with fast, cheap fees, fast transactions, cheap transactions, and a better UX, all the while using L1 liquidity and using DeFi applications that live on L1, that have a lot of advantages around L2. So I'm going to try to explain how is it. I want to underline that this is very much an open field. So if you have questions around about it, don't hesitate and ask them. And if you want to try and build stuff in that field, reach out. I'll be more than happy to give you pointers on how to explore that land. So before we start, I'm Henry. I'm a developer advocate for Starknet, where I work at Starkware, which is the company that develops Starknet. I'm based in Paris, and you can reach me on Twitter or on Telegram. We have a booth over there, so don't hesitate and come say hi. So what am I going to talk about today? First of all, I'm going to do a very quick refresher as to what are validity rollups or ZK rollups and how they work. Then I'm going to talk about messaging bridges and protocols. And then finally, I'm going to explain how that all results into what DeFi pooling is. So first, let's talk very briefly about validity rollups. So who here in the room is somehow familiar with validity rollups or ZK rollups? Can you raise your hand? Nice, so a few of you. So for those of you who are already familiar, I hope I won't, it will be fast, don't worry. So first, let's reintroduce a concept that are validity proofs. Validity proofs are really the basis of what validity rollups are. And they're essentially a cryptographic tool which you can put in the same category as, say, hashing functions or digital signatures. They are mathematical tools that are they are based on mathematics. You can dive into how they work if you want, but if you're building an application, you can also just use them in your application. And validity proofs allow for the following. They allow one person to run a program and generate a proof of execution of that program, meaning they run their program, they get the output, and they also get a proof. This proof is like a value, a number, and by sending this proof and the output to another person, this other person can use these two elements, put them in another mathematical instrument, and verify that the program was executed correctly, and that indeed it yielded that input. So in other words, it allows person A, Alice, to execute a program, and it allows person B to verify that the program was executed correctly, and trustlessly exploit the result, because they know mathematically that this is what the program yielded. Now, where this gets really interesting is the following. There is an asymmetry between proving and verifying. When you're proving a big program, it takes longer to verify on the other end, but it gets exponentially cheaper, meaning the bigger the program, the lower the marginal cost of verification per unit of compute. So it introduces an asymmetry between the person doing the calculation and the person verifying the calculation. All right? So these are validity proofs in a nutshell. Now, how do they relate to blockchain, and how do we use them in the blockchain world? Well, here is what validity rollups are in a nutshell. Validity rollups are blockchains. They have blocks, they have transactions, they have smart contracts, and these blockchains are executed by entities which are called sequencers. And every now and then, let's say every 100 blocks, these sequencers generate a proof that the blockchain moved from block 0 to block 100 correctly. And that proof gets sent to Ethereum in a smart contract where it is verified. So in other words, this blockchain is executed by a big machine, and it can be verified by small machines in a smart contract on Ethereum. And the Ethereum blockchain has certainty that the blockchain was executed, the off-chain blockchain was executed correctly, because it has this proof and it is able to interpret it. All right? Now, what is really nice with that setting, when you start thinking about it in different terms, is that, to the best of my knowledge, this is the only instance where you get blockchains talking to each other natively. Think about it. When you are using a bridge that relies on validators signing messages, what you're really doing is you're asking blockchain A to interpret something that is coming from blockchain B, but the only way blockchain A knows that blockchain B did something is because a bunch of humans signed messages to say, yes, yes, this is what happened. Right? So you're relying on a human translator. Taking the example of, say, Bitcoin, for example, there's no way for Ethereum to actually validate what happened on Bitcoin, because running a full Bitcoin node on Ethereum would be way too expensive. Well, with validity proof, you get to prove the blockchain and use that result in Ethereum, so they can actually understand what happened on the other end without human translation, just based on mathematics. So the cool thing with validity rollup is that they allow you to pass messages. So now I'm going to talk a little bit about messaging bridges and how they relate to validity rollups and DeFi. So first of all, let's define what cross-chain protocols are. Cross-chain protocols are essentially a way for L1 and L2 to exchange messages. When you think about bridges these days, most of the time you think about asset bridges. You think about bridging NFTs, you think about bridging tokens. Reality is you can do a lot more with blockchains than just manipulating tokens, right? You can manipulate permissions, you can maybe delegate execution of code or this kind of stuff. So cross-chain protocols are really not about moving assets, they're about moving data. They're about exchanging instructions and coordinating behaviors of smart contracts on L1 and on L2, right? They allow smart contracts on both chains to interact with each other and be a meaningful whole without having to rely on humans. Now, if you think back at what DeFi is sort of similar, right? There are protocols, there are a set of rules that govern how you move assets around in the blockchain, in Ethereum. And usually, most of DeFi applications rely on input that comes from L1, right? It comes from a transaction, it comes from an Oracle update, it comes from a liquidation event, something like that. Now, the concept of DeFi pooling is really simple. What happens if you connect both of this world? What happens if you use a DeFi protocol and you connect it with a cross-chain protocol? What happens if you link an L1 DeFi liquidity pool with stuff that are happening on L2? Another way of looking at it is the following. Right now, when you think about DeFi on L2, what most protocols do is just clone their application on another layer. You have a lending pool on L1 and you just instantiate the same lending pool on L2. Meaning what you're doing is just fragmenting liquidity, and usually you will have one pool which is much deeper than the other. And this makes it really hard for the second pool to live because users have no incentive to pool in that pool, even though the other one is much harder to use and much more expensive because it lives on L1. DeFi pooling is really about not cloning your application, but extending it, adding extra functionality on L2 instead of duplicating functionalities. Okay? And that gives you a lot of power because now you're able to get the best of both worlds. You're able to give to your users experience that is much cheaper, much faster, it's L2, right? And much better UX. With change such as Starknet, you get to leverage account abstraction, which enable experiences for users that are far better than whatever you could imagine on top of Ethereum. And you also get the best of L1 liquidity. You have a much bigger pool of pools, right? There's much more applications living on L1 than living on L2. These pools are generally much, much deeper, so liquidity is more efficient. And you also get best security because it lives on Ethereum. It doesn't live on another chain, right? So let's see examples of what DeFi pooling is. And what I want you to come home with is not necessarily those two use cases. These are interesting use cases. I want you to come home with knowing that extending your protocol to L2 is a very powerful way to give access to your protocol. If you have an L1 protocol, give access to more people. And if you don't have a protocol, it's a way to provide access to existing liquidity pools on L1 with much better UX. So let's look at a case study. The first one would be batching user actions. The issue, one of the big issues with DeFi on L1 right now is that it's expensive to do transactions on L1. So it may not make sense to deposit money in, say, a curve pool if you have only $10 or $20 of liquidity. So what do you do then? Do you just do it on another chain? Well, one way to do it with L2 would be the following. On L2, you gather users. They will deposit money on your protocol on L2. So they will deposit, say, USD on your protocol on L2. Every now and then, you will get a message moving from L2 to L1 that will, at that point, actually move the funds on L1. So if you have 100 people doing transactions very cheaply on L2, at some point, the L2 protocol will send a message and just move everybody's money in one transaction to L1. That sounds simple. That's because it is. That's what Yearn is doing, but directly on L1. But now you get to do it on L2. The cool thing about this thing too is that if you build your protocol in a smart way, you can actually tokenize the, like say for example, let's imagine with the Aave lending pool, if you're depositing USD and you get AUSD, you can actually give them AUSD on L2 and they get to exchange it with the AUSD equivalent, which is on L1. So what you're doing with that really is just tapping into L1 liquidity and using L2 user experience. There's not much more to it, right? It looks simple. That's because it is. There's a lot of things to do with that. Another interesting example I like to take is using Starknet for DAO treasury management. Right now, most DAOs that live on L1 have a very big problem with the engagement of people. Voting is very expensive on L1, so most people don't vote, so you don't get a lot of participation in your DAO. The other solution is to use something like Snapshot, which is great. Snapshot is a wonderful system, but it doesn't have teeth. It's just signaling. It's entirely off-chain. So you rely on Snapshot to collect voters' intention, and then a multi-sig is tasked with enforcing those decisions. Well, here, you could imagine having a system where you get the best of both worlds again, and you have your governance on L2 and your liquidity on L1. So you get your brain on L2 and your muscle on L1. Because yeah, we didn't talk about the other side of that. What happens if your DAO fully lives on L2? Then you get people to vote for not a lot of money, but then liquidity pools are not great or they're shifting more, so your assets are way less efficient. So what you can do in that case is basically have a set of smart contracts on L2 where people vote, take decision on capital allocation, and you pool their results, you count their votes, and you reach a decision. And once that decision is reached, you send a message, the smart contract will send a message to L1 that will execute some action. You can actually use ready-made tools for that. If you use a multi-sig contract and you just connect it with L2, it can take instructions from L2 and just execute them on L1. You don't have to change a lot of stuff for it to be efficient. I want to mention that those two use cases are not something I just made up. There are smart people already, smarter people than me, working on this thing. Snapshot, which I mentioned, is working on Snapshot X, which is actually even more involved than what I just described. They're working on the system to collect all the user votes off-chain, the signatures that you're currently doing with Snapshot, count them as is in a smart contract on Starknet, and then use this count to send a message to L1 and execute and enforce decisions on L1. And the part about depositing, batching user funds on L2 and then sending instructions on L1. You have Aave making experiments around that. You have Maker who are doing experiments around that, and a lot more people. Something that is also really interesting that I want to mention is that right now, if you're an L1 project and you want to bridge your token to L2, oftentimes you have to go through a specific bridge, register your token, and then you don't have a lot of flexibility of how your token will behave on L2, right? Maybe it's a standard contract that is deployed for you on L2, this kind of stuff. Messaging bridges and having a tight connection to L1 allow you to design your own bridge and to actually operate your token and your bridge token exactly the way you want. So Maker, for example, is operating their own bridge, their own Starknet bridge, and they're fully in control of the representation of their token on L2. All right, and that's about what I wanted to present. So there you go. So to sum up what I discussed, DeFi pooling is essentially a new primitive you can use in DeFi. It's about not just using input that comes from L1 interaction, but using input that come from L2 interactions. This is something that wasn't possible before because up until then, whatever was coming from outside the chain was trusted. You relied on validators, you relied on people signing information, and they had control over your protocol. Now with validity proof, you can do this in a fully non-trusted way. It's a really exciting primitive because it allows you to do a bunch of stuff, but one of them being to expand your user base. Right now, DeFi is very hard to use. Blockchains in general are very hard to use, but L2s are a bit easier to use. So you get to have more users for your L1 application, all the while having more efficient liquidity. I also want to mention that this is very much an unexplored territory. There are a lot of things to build using this messaging bridge. Some people are really into it, but you should be too. Like you're very welcome to come and experiment. I'm going to be doing a workshop later for ETH Prague, where I'm actually going to take you through how to deploy your own bridge. I'm going to explain to you how to write the solidity part to receive input from L2, and I'm going to teach you how to write the L2 part that receives input from L1 and how you can get started experimenting with that. It's also something that can be very useful for you to experiment during a hackathon. So yeah, come to this workshop if you're interested in making this work. We also have a booth down the hall, and come say hi. We'll be happy to help you out. Are there any questions? Yes.
Thanks for the chat. It's a very interesting topic. One of the field, arguably most important we need is liquidity depth for AMMs. That's what the industry desperately needs. But I fail to see how this could work with your aggregating.
You're right. AMMs are a more complicated topic. The system I described works well for, it works really well for lending. For AMMs, it's more complicated. So I'll say it this way. This is a nut that hasn't been cracked yet. There's no reason why it can't. So I think there's you can imagine a lot of different ways you can do that. And I don't know what's the right recipe, but at least here, I don't know. It's I don't have a good design for that, but it's definitely an interesting area of experimentation. Yes.
Hi, I wanted to ask about the so the messaging layer and the storage proofs part. That's fine. I was just curious about the DeFi pooling part on the L1. How is this pooling happening actually on a smart contract level? Are there any implementations that are like you feel like are similar direction one should be looking at to explore how the DeFi what is DeFi pooling on a smart contract? What does it look like on a smart contract?
What is DeFi pooling on L1?
Yes,
Right?
and what sort of ways of doing it that can be efficient for this use case?
Yeah, sure. So, for example, taking back the example I took of batching user deposits, you would have an L1 contract that is able to hold assets, right? When L2 users send USD to the L2 DeFi pooling, then the L2 DeFi pooling at some point will withdraw money from Starknet, and it will withdraw money to the DeFi pooling counterpart on L1. So now that DeFi pooling contract on L1 will hold these funds and will be programmed to deposit those funds and put them to work in any kind of pool. So it's about, you have contracts on both sides, and it's just about, like, think about it kind of like Yearn in a way. You have a factory or you have a contract that is able to move money around. It receives specific inputs from time to time, but instead of receiving these inputs directly from L1, it receives them from L2. Does that make more sense? Kind of. Okay. Any questions?
Thank you for the talk. So I wonder, as far as I understand, correct me if I'm wrong, that in this rollup space, Starkware is kind of special because it doesn't strive for EVM compatibility, whereas other projects want to be as compatible as closely as possible. How does this distinction correlate with the issue that you've described? So pooling, is it easier if you're EVM compatible or not, or is it just an orthogonal metric that doesn't have any influence here?
That's a good question, and I don't know about that. I think it's still very much early, and I would be very interested in talking with teams who are taking this approach either on zkVMs or on zkVM and to get their insights on that. So yeah, I don't know.
Hello.
Hey.
I wanted to ask if there is any latency between the layers. I mean, how do the layer 2 users know that the state of the blockchain they are experiencing is the same as is on the L1 and it did not change since the last update?
Okay, so your question is about latency, is that correct?
Yeah.
Yeah. So messages move from L2 to L1 at a specific pace. So L2 to L1 messages move every few hours. L1 to L2 messages move every few minutes. Now, how are users aware of this? That's up to you. That is how you design your application. Do you want to give them an instant token that has value, or are you going to put this in a pool and then transfer them token later on? It's really up to the app developers to give visibility on that or to abstract it away. But it's kind of like, again, like applications like Yearn who pool user deposit to then deposit later on, or Lido, for example. This is very much about how you define your application. It's not necessarily a technical issue. Does that make sense?
Okay, thank you.
Any more questions?
I'm thinking now about Yearn. Here's another fun thing that was done by Yearn. Actually, it's an experimentation, but you know that Yearn has these concept of strategies where, depending on the best way you allocate liquidity, they will change the parameters of where they allocate liquidity, right? All of that calculation is done off-chain, and then a multi-sig will say, yes, this is the best strategy, and they will implement it on-chain. In other words, Yearn strategy relies on multi-sigs. They recently did an experimentation where they wrote the best strategy allocation algorithm in Cairo, and they proved that this strategy is the best one. And then they use that output to change the result on chain. So they used provable code and validity rollups to make their system safer. Anyway, just the fun stuff also you can experiment with validity rollups. All right, I think I'm done with my presentation. Thank you for listening to me. Don't hesitate and come and ask questions.